For section 4.3, we're going to be continuing our probability with the addition rule. The key phrase you need to focus on here is that we're going to be using the words and or. So and we sometimes will use the symbol like this for and. This is exclusive. Meaning what? Well, if I said, how many students in here are male and wearing pants? Well, what happens? Who gets to raise their hands? Only the males wearing pants. If I said males and wearing shorts, only people who are male and wearing shorts. It is actually exclusive. It is a smaller group and it excludes people, right? If I wanted to include more people, I would use the word or. And the symbol for that is here, the or, and that is more inclusive. If I said how many people in here are male or wearing pants, well then who could raise their hands? Any males or anyone wearing pants, no matter what the gender. So or is more inclusive. This kind of bothers people, but think about it this way. I always like to say, right, when girls you say, oh, describe the perfect guy. They go, well, he needs to be this and tall and rich and lots of hair and nice car and they're being exclusive, right? To the point where the guy no longer exists, but that's okay. You want to be exclusive because you want to be like, well, he could be this or this or this or this. Then it'd be like, well, what the heck? Anyone will do, right? And that's not the way you want to handle relationships. So, and is exclusive or is inclusive. It includes more people in a larger group. So, if I talked about the probability of A and B, I'll start with that one. It is basically going to be the overlap of A and B. It is going to be the small group. If we say A or B, it'll be the probability of A or B or both. And the way we calculate that is that we add them. Or means we're going to add. That's kind of the useful thing. So probability of A or B means we are going to add the probabilities. But we have to subtract the overlap. Subtract the overlap. Well, why do we subtract the overlap? Well, it's easy to show you. If I wanted the probability of a green leaf or a purple flower from this table, well, I have the totals we can calculate. Let's see. Total green leaves are 8. Total purple flowers are 9. So if I said green leaf or purple flowers, I should get some totals. So this is 6 yellow, 5, 9 and 5 is 14, 8 and 6 is 14. So our total is 14. That's our N, kind of our complete total, right? So with the probability of getting a green leaf, well, there are 8 green leaves out of 14 total. Or means we are going to add the probability of getting a purple flower. Well, there were 9 purple flowers out of 14. Well, why don't I just say the answer is 17 out of 14? Well, first of all, that's nonsense. You can't have 17 out of 14, right? But the issue here is what? I added this whole group, those 8. I added this whole group, those 9. So basically, what did I add twice? Well, look at that 5 got circled twice. That is the overlap. That's why we subtract away the probability of purple and green, which is the 5 out of 14. And why? Because we added that 5 in this 8, and we added that 5 in the 9. It got added twice, so we have to subtract it away once to balance it out. So we don't get 17 out of 14. What do we end up with? Well, 12 out of 14, or 6 out of 7, or 0.8 something, right? And I'll keep going back to the calculator, but 6 out of 7, so 6 divided by 7, 0.857. And this is going to keep doing that, so that's all right. So 0.857. So notice what? Or means we are going to add, but we have to subtract that overlap. Somebody would have just looked at this table and said, just add the 4, the 5, and the 3. That gives me 8, 9, 10, 11, 12 out of 14. That will work this time, but I'm telling you, this is a formula you do need to know, and because I may not give you a table. So you need to make sure you know how to use that formula. What if we said green leaf or white flower? Well, what's the probability now, I'm going to erase these real quick, of a green leaf? That would be, the green leaf would be 8 out of 14 again. But this time it said, or white flower. How many white flowers are there total? 5 out of 14. Or will mean that we are going to add those. But what happened? Well, when I added this 8 and I added this 5, that overlap got counted twice. What group got counted twice? The green and white flowers. So since we counted it twice, we subtracted away once. So we don't end up with 13 out of 14. We end up with 10 out of 14, 5/7, 0.7 something, 5/7, maybe. Oh my goodness gracious. Anytime, 5/7, 0.714. Okay. So here's the formal addition rule. A or B, we add them and subtract away the overlap. If a person is randomly selected, find the following probabilities. Okay, so you are either blood type O, A, B, or AB. You are also, you may say A positive or A negative. That's basically what are the RH level. You're either positive, you have it, or negative, you don't have it, right? So what is the probability of getting someone who is not in group A? Well, that's not tough. Well, let's see. Let's get some totals first. So 39 and 6 is 45. This is 40. This is 10. This is 5. We're looking at 80, 90, 100. This is not going to be as fun, but this should be 11, 13, 14. This should be 12, 47, 70, 86. And check the total, that going either way, it should total to 100. That helps me make sure I didn't make any mistakes there, okay? So this not group A, we've seen this before. This is basically the probability of a complement. What's the probability of not being in group A? Well, there are 40 people in group A. So how many people are not in group A? Well, the other 60, or 0.6, or 60%. Now, I did that pretty informally, but you could do 1 minus the probability of A. So 1 minus the 40 out of 100, which would be 0.6, or 60%. What is the probability of getting someone who is type RH negative, who basically has a negative? Well, there are 14 who are RH negative, so getting someone who is RH negative would be that 14 out of 100, 0.14, or 14%. What's the probability of getting someone who is in A or B? Okay, well, the probability of A having blood type A is the 40 out of 100 plus the probability of group B. There was 10, so the probability of group B would be 10 out of 100 minus the overlap. That is somebody who is both type A and type B. And this time that would be 0. Why? Well, if you're AB, you're not both A and B. You are just AB. You have a mix of the both. This is saying only type A and only type B. See, we added this 40 and we added this 10. What was the overlap this time? Well, there was no overlap, right? So there is nothing to subtract away this time. It would just end up being the 50 out of 100 or 0.5, or 50%. What is the probability of getting someone who is group B or Rh positive? So group B is these 10, or Rh positive is that 86. Am I going to just add them this time? Am I just going to add the 10 and the 86? Well, let's see. So it would be B, which was 10, Rh positive, which was 86, minus the overlap. Is there a B and and Rh positive? Right? Is there an overlap? We'll look at the circles. Was there an overlap? Yes. That would be the 8 people that are both counted in the 10 and the 86. So since we counted them twice, we subtract them away once, leaving us with 88 out of 100, 0.88, or 88%. Here are some projected numbers in thousands of earned degrees in the United States in 2010-11 academic year. Find the probability a degree recipient chosen at random is a female. Go through. You need to be able to total these up. Okay, so the total females, that looks like it's what? 77, 4, 79, 82, 12, 5, 12. Is it 14, 12? I can't do this in my head. Go back and check it. 60, 70, 330, 991. Let's just check that one. 933, 402. 933, 402. What was it? 51 and 26. $14.12. Hey, look, I can't do mental math. And this was 70, 330. I'm good with 991. So our total there is what? 3, 0, 14, 2403. Looks right. Going down here. 4, 9, 15. Going down here, 662. Down here would be 95. And down here would be 52. Let me just double check. 1594, 662. 1594, 662. So 1594, 662 plus about 95 and 52. And this should be our total, 2403. 2403, I'm feeling good about this. Find the probability a degree recipient is female. Well, how many females are there? Well, that's just the 1412. So the probability of a female is the 1412. Sorry about that. Ooh, Lordy. All right, we can do this, I promise. You're like, I'm getting sick. Toughen up, Buttercup. All right. Sorry, how many females were there? How about 1412 out of 2403? Yes, I will want that as a decimal. So 1412 out of 2403 is... This thing works better sometimes than sometimes it doesn't. How about 58 from random to the third decimal place? 588. Find the probability a degree recipient chosen at random has a master's degree. Well, how many master's degrees are there? That's the 662. 662 out of 2403. So 662 out of 2403. Two 403. How about 0.275? So 0.275. My dog is snoring in the background. Hush. Find the probability a degree recipient is female or has a master's degree. Well, I can add the females plus the master's degrees. But we just added all the females, all the master's degrees. Were there any females with master's degrees? He was like, no, of course not. Well, you're a chauvinist pig. No, there were. There were what? 402 people that got counted twice. So we take away that 402 out of 260. Nope. Shimmy. Out of the 2403, we take away that overlap. They got counted twice. Okay? So 1412, 662, 402. Let's see. 1412, 662, minus, I believe it was 403. Double check that. 402. See, I'm already getting myself in trouble. 402. So there is 1,672 out of 2403, or 0.696. So 1672 or 0.696 out of 2403. So I'm hoping this isn't too bad. Like I said, the big thing is the addition rule. If we use or, the good news is or will always mean add and subtract potential overlap. And it gets a little trickier. Here it's not hard. You just find the overlap. And is the overlap. When I'm dealing with multiple events later on, the and gets a little trickier. It's not that bad. So just make sure you're solid here, and we'll keep building on it. We're going to call a household prosperous if its income exceeds $100,000. Call the household educated if the householder completed college. According to the current population survey, probability of randomly selected household is prosperous is 0.138. Okay. The probability of prosperous, PP there, is 0.138. The probability household is educated is 0.261. And the probability of both is 0.082. What is the probability that you are either prosperous or educated? What's the key word here? To get the probability of prosperous or educated, we are going to add the probability of prosperous plus the probability of educated minus the overlap. So probability of prosperous plus the probability of educated minus the overlap. So what is that? 993. So 0.339 minus 0.082. Got 0.317. This is not the only option with this. I'm going to go ahead and move that over here. So basically, what do we get? 0.317. All right. All right. This is not the only option with this. You can actually make a table if you want to. I would encourage you to write this down because there's a quiz question that's kind of difficult where this could help with. But basically, I could make a table because I have two different events I'm looking at. You are either prosperous or educated, or not prosperous or not educated. and they've given some of these numbers already. The probability of prosperous is this 0.138. That's the total for probability of prosperous. That's 0.138. That's the total probability of prosperous. The probability of educated is 0.261. That would go on the outside. That's the total, 0.261. Where would this 0.082 go? Well, it's the overlap for prosperous and educated. So it would be 0.082. What we need to know is that what are the probabilities going to total up to? Well, the total should be 1, 100%, right? So if there is a 0.138 chance of being prosperous, what's the probability of not being prosperous? Well, that would be the complement of that, or 0.862. How did I get that? That is 1 minus 0.138. Goes right there, because it should be the complement of P. Same with this. If the probability of being educated is 0.261, what's the probability of not being educated? Well, that would be the complement, 0.739. These should total to 1 on the row or the column. I could also fill out the rest of this table and say, what's the probability of being educated and not prosperous? Well, this totals to 0.261, so it'd be 0.261 minus 0.082. Or, oh man, 259, 17.179. Because these should total to 0.261. These should total to 0.138. So I can subtract away and figure out what goes in here. It would be a 6 and a 5, so 0.056. These should total to 0.138. And I can do the same thing to figure out this last little piece. 0.739 minus 0.056 would be 0.683. And totaling down should total to a 2, a 6, and an 8. And it does. So, I mean, this is a little more advanced, but I'm telling you, if you can make this table, I could ask any question. I could say, what's the probability of being not prosperous and not educated? And you could now answer that from the table. So I could ask much more difficult questions just by knowing how to make that table. Understanding that these should total to the total probabilities where the pieces go, and understanding the total probability is 1. Okay? All right, and last but not least, when a single card, well, I say that, there are 2 options here. Okay, I need to pay attention. 2 more things. All right. Determine if the following events are disjoint mutually exclusive. What does that mean? Well, that would mean disjoint means that there is no overlap. So basically that means that the probability of the event A and B both occurring is 0. We've seen that before. Let me go back up here. Where was it? Do you see this big old fat 0 right here? In this situation, these were disjoint events. They were disjointed. Why? There was no overlap. There was no overlap there. So, can I get a card that is a 7 and a jack? You need to know some basics about cards, okay? So what do we have here? We have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay? But we have that occurring for both hearts, diamonds, spades, and clovers. And I know they don't call them clovers, but clovers. And my pictures suck, I understand. But this basically occurs for all 4 suits. So can I, if I'm pulling out a single card, get something that is a 7 and a jack? Well, here are all the 7s. Here are all the jacks. Is there an overlap? No. If there is no overlap, then they are disjointed. Can I have something that is a club and a king? The club, the clovers there, right? The king, all the kings. Is there an overlap? Is there a club king? Yes, there is. So if there's an overlap, these are, what's the opposite of disjointed? Somebody's like, I don't know, jointed? No, we are not druggies. We don't call them jointed. We call it not disjointed. I understand that it sounds like ridiculous in English that we say not disjointed, but we do call it disjointed and not disjointed. Okay? Can you get a face card and an ace? What's a face card? Well, the Jack, Queen, King. Why do they call those face cards? Literally, the cards have faces, so they call these the face cards. Okay? So, can you have a face card and an ace? Well, these are all the face cards. These are all the aces. Is there an overlap? No, there is not. No overlap means disjointed. Can you have a face card and a spade? Here are all the face cards. Here are all the spades. Are there face cards that are spades? Yes. There is a king, queen, and jack of spades. So therefore these are not disjointed. Okay? Another way of thinking about disjointed, if you do sports and you have like an injury in your shoulder or your knee pops out, that's really painful. Some of you are shuddering right now. But that is called a disjointed tendon or disjointed shoulder or disjointed. It separates. There is no overlap. It pops out. That's the idea. Disjointed. I have two things, two events, and there is no overlap. Disjointed. So that's your shoulder, that's your rest of your body, they're split apart, it's disjointed. Ugh. If there is overlap between the two events, then we call that, so there is overlap, then we call that not disjointed. Okay. Determine if the following events are disjoint. I think I should say Ed, but I'm okay with that. Can you randomly choose a movie starring Leonardo DiCaprio and randomly choose an R movie? Is there an overlap? Are there Leonardo DiCaprio movies that are rated R? Is there probability of getting a Leo movie and having it be rated R? Well, unfortunately, yes, right? There's that one where he's like, I don't remember. See, and this is where the class would come in handy, but I want to say Moneyball, whatever it is, but he basically does, Wolf of Wall Street, that's it. And he does all these other crazy movies. Yes, there are rated R movies that are, so yes, it exists. Therefore, there is an overlap, which means it is what? Could you randomly select someone who voted for Barack Obama and randomly select someone who's 16? Is there somebody that you know who is 16 and voted for Barack Obama? Can you have somebody who voted for Barack and that person is 16 years old? Well, hopefully not, unless you know some like voter fraud that I should know about. You can't vote when you're 16, right? So this is impossible. There is no overlap, therefore it is, right? I'll just put no right here first. No, it does not exist. No, it does not exist, which means it is disjointed. Can you randomly select someone who owns a dog and randomly select someone who owns a cat? Can there be a person who has both a dog and a cat? Yes, these weirdos exist. If there is an overlap, that makes it what? Not disjointed. So there are people that are not cat people, not dog people. They are both dog and cat people. Or maybe the wife is a cat person and the husband's a dog person, right? That was stereotypical. But the idea is what? You can have somebody that has both, owns both. So that's it. Not a whole lot. Work through the sections and see me if you got any questions.